Hi guys, my name is Terry. In this video, I'm going to go through Additional Mathematics State Trial Paper exam for year 2024. And this is SPP Sekolah Berasrama Penuh Paper 1. Okay, let's begin with the first question. This is from Form 4 Chapter 8 Vectors. So diagram shows OA, vector OA, OQ, sorry, which is A, vector OP, which is B on square grid. So you're supposed to express OR in terms of A and B and RS in terms of A and B. So for OR, right, if I want to go from O to R, let me highlight for you, this is O, this is R. You can do A first followed by B or B first followed by A. You can also do combination zigzag, B, A, B, A, B, and so on. So I think maybe I just do, we do A first. So I can see I can go 1A here. But if I continue with B, right, B is actually a 1 by 2 diagonal. You notice it's not going to end up at point R. So 1A is not enough. So let's do 2A. 2A is up here, followed by 1B, 2B. So in order to go from O to R, notice you have to do A twice and B twice as well. So therefore, your vector OR will be 2A plus 2B. Yeah, fairly simple. 2A plus 2B. You can see from my diagram. Now, if I want to go from R to S, this is also very simple. You notice that OP and RS are actually parallel, but they're going in the opposite direction. OP is going up, the blue line is 1B, but you're going in the opposite direction. So this is negative 1B. There is another one, negative 1B. Another one, negative 1B. Another one, negative 1B. So total, you have 4. Yeah, so it's equals to negative 4B. Yeah, also a very simple question. Okay, question number 2. This is from Form 4, Chapter 6, Linear Law. Diagram shows a curve y equals to minus 2x squared plus 4. It's a curve. It's expressed in linear form y equals to 4x plus c. You're supposed to express x and y, capital X, capital Y, in terms of small x and small y. So let's begin with this non-linear form. Y equals minus 2x squared plus 4. So if you want to convert to linear form, right, you can see actually the question made it very, very clear. Why? Because they already show us this y-intercept is negative 4, negative 2. And the gradient here is already 4. So we know we have to take this equation and divide it by x squared so that you get y over x squared. This becomes negative 2. And this is now 4 over x squared. See, immediately you can see that your y-intercept is minus 2. Remember, your y-intercept shouldn't have any term with x or with y. So then I rearrange it. At the same time, I take out 4, left with 1 over x squared here, minus 2. So when you convert to linear form, this is your big Y, this is your gradient, this is your big X, and this is your C. Your y-intercept is negative 2, your gradient is 4. Now with that, we can conclude, yeah, I've already converted this to linear form. Actually, you can just stop here. You don't have to draw the arrow, yeah? So we can, okay, what we need is to find what is your big Y. Your big Y is y over x squared. Your big X is 1 over x squared. And also for part B, you're supposed to find the gradient of the curve, right? Usually the question made it so easy. It's here. You can see from the equation given. Right? So what is your gradient? Your gradient is 4. So in fact, I always say they shouldn't tell us this, right? But they have. So yeah. So you know your gradient is just 4. Okay, moving on to question number 3. This is from Form 4, Chapter 5, Progression. So here we have 3 consecutive terms of an arithmetic progression. They are given as P, Q, and R. You're supposed to state the relation between P, Q, R. Okay, so number 1, we know if we want to find relationship between them, we can say if it's arithmetic, right, the second term divided by the first term must equals to the third term divided by the second, sorry, this is arithmetic. The second term subtract the first term must equals to the third term subtract the second term. Difference, a common difference. It's geometric, we divide. Arithmetic, we subtract. Now, your second term is given as Q. Your first term is P. your third term is R, second term is Q. Now, actually, by right, we shouldn't say it's not necessarily a first term, second term, because they say 3 consecutive term, but it doesn't matter. It appears to be the same, right? Or if you want, you can say Tn plus 1, right? This is this second term. We start with N. This is the third one. N plus 2. This will be N plus 1, but doesn't matter. We know that we don't know where's the starting, right? It may not be the first, second, third. But if let's say this is Tn, this is Tn plus 1, this is Tn plus 2, right? So let's make Q as a subject, bring the Q together. 2Q equals to P plus R. Q is therefore R, P plus R divided by 2. Now, you form, because it doesn't matter. The question says state the relation. They didn't say that you have to make Q. You make P as a subject. But because we have 2Q here, we cannot just leave it like this. We could group the Q together. That's why I wrote put 2Q together. You can stop here. You can write 2Q equals P plus R. You want to make Q a subject, you want to make R a subject. It's fine. Yeah. Okay. Because it's general. You can use any one as a subject. Okay. Now, the first 3 terms, next one, part A is arithmetic, part B is geometric. The first 3 terms of a geometric progression, yeah, they are given as this. So for geometric, we take the second divide by first equals to the third divide by second. The second term is x, first term is x minus 4. The third term is 5x minus 12, second term is x. So here I'm going to cross multiply. X times x is x squared. Here we have x minus 4, multiply with 5x minus 12. So as we expand this, you get 5x squared minus 12 minus 20 minus 32x plus 48. So I'm going to bring the x squared to the right-hand side. I'll have 5 minus 1 is 4 for x squared minus 32x plus 48 equals 0. We can divide everybody by 4. As you divide by 4, this will be 8. This will be 12. Now, let us factorize. You have 2 answers here. One of them is 2. Another one is 6. Yeah, factor of 12 is 2 and 6. You get 8. So your x is either 2 or 6. Take these 2 answers, sub inside the equation. Why? Sub inside here. Because we don't know which one is valid, which one is not. Yeah, sometimes you may have to reject one of the answer. Now we know that if although they both appear to be x and y, x and the 2x value 2 and 6 appear to be positive, but because the question say the first 3 terms are all positive, the 3 positive term, right? So if you sub inside the first one, right, your T1 will be 2 minus 4. You get negative 2. We know we have to reject. You can't get negative, right? And your second one, your T1 is 6 minus 4, which is 2. So since your terms are, all the terms are more than 0, positive, therefore, only one answer for x. X is just 6. Okay? If you put 2 inside, you get negative. If you put 6 inside, you get positive. Okay? You don't have to test the next one already because we know one of them is off already. We tested with 2. We know it's off. Has to be 6. But if you want, you can put inside 5 times 2 is 10. 10 minus 12 is negative, right? If you put 6 inside, 5 times 6 is 60. 30. 30 minus 12, again, is positive. Okay, question number 4. This is from Form 5, Chapter 3, integration. So diagram shows part of the curve y equals to 12 over x squared. You're supposed to find the area of shaded region A. So here we can, for the first part, we can just integrate. Your area will be integration of 1 to 3. Your function is 12 over x squared dx. Okay, for me, the way I integrate this, right, I like to, use this formula k over x power n. Right, is faster. I notice a lot of people bring it up, integrate, bring it down. They have to use 3 steps. For me, I use a negative in front. It's a valid formula. You can use k, you can use a, it doesn't matter. So normally for a, x, n, right, if it's power positive, we just copy a, copy x, increase the power by 1, divide by the increased power. Okay, but here we put a negative in front. we copy A. Your A is here. You copy X, increase, instead of increasing the power, we reduce the power by 1, put the reduced power in front plus C. So how do you apply this? We put the negative in front, copy 12, copy X, reduce the power by 1, put a 1 in front, 1 to 3. Now, whether you want to put a 1 in front or not doesn't matter, so I don't think we need to write that. Now, let us substitute the limit. You can choose to take out the negative. If don't, it's okay. So it's 12 over 3 minus negative 12 over 1. So 12 over 3 is 4. 12 over 1, this one is 12 as well. So 12 minus 4, answer is 8 unit. You can always use your calculator to validate your answer. So you can see from here, I integrate. Yeah, the integration button is here below your menu button. Take 12 over x squared. Lower limit is 1. Upper limit is 3. Your answer is 8. All right, that is part A. So part B, they say that find the value of P such that region B and C have the same area. B is the green one, C is the pink one, right? They have the same area. So we just use back the same formula, integration 3 to P, but the limit is different. 12 over x squared dx, this is B, equals to C. C is P to 5, 12 over x squared dx. So when you integrate, you're going to put a negative in front, copy 12, copy x, right? Reduce the power by 1 is 1, okay? And this is 3 to P. Same here, put a negative in front, copy 12, copy x, reduce the power by 1. 1, you want to put a 1 in front, P to 5, because it's the same formula, it's the same function as above. Now, let's put the P, substitute the P. Now, in fact, before you even substitute, right, you notice there's a negative here. You can just cancel negative to make it easier. You don't have to write negative on both sides. So we write 12. In fact, the 12 also I'm going to cancel. Yeah, we can cancel the 12, right? Cancel the 12 as well. So you can put P inside. 1 over P minus 1 over 3 equals 1 over 5 minus 1 over P. Now, let us group the P on the same side. When you bring this P to the left, this to the right, so what you have is 1 over P plus 1 over P is 2 over P. This will be 1 over 3 plus 1 over 5. Okay, it's going to give us, let's continue here, 2 over P is going to give us 5 plus 3, 8, 8 over 15, right? So the 2 and 8 also we can cancel. We can simplify this, left with 4. So you just invert. P is 15 over 4. You can't do mentally, you can use a calculator, or you can change to decimal. 15 over 4 is 3 point something, 3.75. Yeah, P is 3.75. Okay, moving on to question number 5. This is from Form 4 Chapter 1 function. So a given function fx and also f inverse. Fx is unknown A, f inverse is unknown B. You're supposed to find the values of unknown A and B. So I think the first part, right, we start from fx, we let f inverse x be y. Let's go and inverse the function. Yeah, I like to write f inverse x equals y. By the way, your textbook uses fy equals to x, or should I say fx equals y. So also okay, you can use any method. So I'm just going to show you this, f inverse x equals y. You switch fy equals to x, you switch x and y position, the inverse disappears. So it looks like this. When you start from x, you go backwards. This result is y. So we start from y, the result is now x. When you switch x and y value, the direction of the function switches. So instead of going backwards, you go forward. So my fx is 4 over x, 4x plus a over y. So this is 4y plus a over 5. Yeah, 4y plus a over 5. We need to make y as a subject. 4y plus a equals to 5x. 4y is 5x minus a, right? Your y is 5x minus a over 4. Now, however, you notice, right, the moment you inverse the function, it becomes 8, right? So this is two different values. So we need to compare. So I think the best way to compare is to change both of them to the same, maybe to two separate terms. So this is your y, right? Your y is your f inverse x. So at the same time, I'm going to split them into a linear form, right? It's actually in the form of ax plus b. So it's linear form, split to 2, right? 5 over 4x and negative a over 4. Then you compare with this one, the second one. Or maybe I use different color. This one, the yellow one. Let's compare with the yellow one. So for the yellow one, right, so I split them into two. So it's b over 8x plus 14 over 8. Now, obviously 14 over 8, you can simplify, but it's okay. We don't need to simplify here now. We just compare the coefficient of x, right? We compare x, you will see 5 over 4 equals to b over 8, right? So you can see, I just use simple ratio. B, 4 times 2 is 8, 5 times 2 is 10, b is just 10. Then you compare your constant. Constant is the one without x. Let me use a different color here. You can see the green one here. There is a negative in front. So we say negative a over 4 is now 14 over 8. That 14 over 8 also we can simplify is 7 over 4. So by comparison, a is just negative 7. The negative is just transferred to the right-hand side. All right. So that is part A. Okay, for part B, you're given function fx and gx. You're supposed to express this in terms of f and g. Okay, actually, there are two ways here. One is by trial and error, right? Another is working backwards. Now, for some of you, one look, you can tell the answer, right? It's fgx. Some people not sure they're going to do gfx. It's okay. You can just try it out, right? So let me just write the first method, trial and error. We go do fgx. What is fgx? Fgx means you're putting gx inside fx. Your gx is 2x minus 3 minus 5. Your fx is 4 over x. Or what is your x? Your x is now 2x minus 5. See, notice you're getting the same answer, right? You're getting exactly the same as this. So it's quite straightforward. But your answer is not this. Your answer is fgx. We want you to find what is a combination of function that gives us this. Okay, so this is part one method. A second method is we work backwards, starting from 4 over 2x minus 5. You know 2x minus 5 is going to give us gx. Yeah, from here, it's going to give us gx. Now, your gx here, right, guys? Your gx here is 4 over gx. So think of this. F bracket is 4 over bracket. So if I put gx here, this will be just gx. So end up, this will give us fgx. Therefore, what is your answer again? Your answer is fgx. Yeah, as long as you show your working is fine. So this one is method 1. This is your method 2. Method 1, we do trial and error. Very simple. Method 2, we work backwards. Okay. Okay, question number 6. Okay, here the following information refers to vectors m and n. Find the value of k if this vector is parallel to the other vector. When two vectors are parallel, the first vector is a multiple of the second vector. That is, the first vector is what? 2m plus n. Parallel, we put lambda. You can use other symbol, but normally we just put lambda. Try not to use kh because here you already have k in vector m, right? So parallel, put the lambda, this is 1 minus 1. So let's put m inside, substitute vector m, 2k, then you plus n, 3, 11. The result, this lambda, you times in lambda, negative lambda. So multiply inside, you should get 4. 2 times 2 is 4 over, sorry, this is not over, this is not fraction, 4 to k, and then this is 3, 11 equals lambda minus lambda. Put them together again, 7, 2k plus 11. The result is lambda negative lambda. So by comparison, right now, let's solve for lambda first. You compare your I component, your lambda is 7. You compare your j component, 2k plus 11 is negative lambda. Since lambda is 7, right? Sub inside. Your 2k will be bring over negative 18. K is negative 9. Okay, question number 7. Here we have a chapter 2 quadratic function question from 4. chapter 2. So you are given a quadratic function fx equals to 4x squared minus 16x plus k, such that k is a constant. So you're supposed to find the smallest value of k such that fx is greater than 0 and k is an integer. So if your fx is greater than 0, right, meaning this graph is always above the x-axis, it lies above the x-axis. If the graph lies above the x-axis, so what can say that this graph, it doesn't intersect the x-axis. So it doesn't intersect the x-axis. The solution for this equation, your fx for x squared minus 16x plus k will be, there will be no solution. There is no real root. If there is no real root, right, your b squared minus 4ac value should be less than 0. Now remember, fx is more than 0, but your b squared minus 4ac is less than 0, right? Because there's no real root, there's no intersection. If it cuts it, if it touches at one point, you have one real root, your b squared minus 4ac will be equal to 0. If it cuts at 2 points, then you have two real roots, your b squared minus 4ac will be more than 0. Okay, my b is negative 16. I square it minus 4. My a is 4. My c is k. The result is more than 0. Okay, 16, if I square it, actually you don't have to square it because you can cancel it, but if you square it, you get 256 minus 16k less than 0. If you divide by 16, this will be 16 itself, right? Bring the k over, k is greater than 16. Now, you need to take an integer value. K is an integer, so the smallest value of k will be 17. Yeah, if it's greater than 16, next integer is 17. All right, that is part A. Well, part B, there are two parts to it. The first part is this. Given that this quadratic equation where fx is equal to 0, they are alpha and beta. Yeah, the roots are alpha and beta. And beta exceed alpha by 1. So meaning you can say beta is alpha plus 1, right? So that means the roots will be therefore alpha and alpha plus 1. Okay, so we can use the SOR POR method. Remember, sum of root alpha plus beta, your beta is alpha plus 1, is negative b over a. Now go back to the equation. Now your a, b, c, your a is 4, b is negative 16, your c is k, right? So your b in this case is negative 16, your a is 4. We can add this together. 2 alpha plus 1 is now 4. 16 divided by 4 is 4. The negative and negative cancel each other out. 2 alpha is now 3. Alpha is 3 over 2. You're supposed to find the value of k. Let's work out your POR. I've got my SOR, sum of roots. Then work out your POR. For those who cannot remember, your SOR, sum of root, is alpha plus beta, negative b over a. Your POR is alpha times beta c over a. So this is the formula. You need to know it's not given in exam. So my POR will be alpha and alpha plus 1 times together. The result is c, which is k over a. A is 4. Now, actually, we know your alpha. Your alpha is 3 over 2. Then 3 over 2 plus 1. This is k over 4. So 3 over 2 plus 1 is 5 over 2. 3 times 5, 15. This is 15 over 4 equals to k over 4. Therefore, k is just 15. Yeah, you're supposed to find the value of k. All right, so that's B Roman 1. Let's keep going. For B Roman 2, they say that now your product of root is 2 alpha plus 5. You're supposed to express alpha in terms of k. Okay, so same thing, but we need to use this, your ABC, we need to do SOR POR, but just focus on your POR because you're given the product of root. We do not know what is your alpha beta, but we do know that your POR is 2 alpha plus 5. So POR is c over a, your c is k, your a is 4, 2 alpha plus 5. And I'm finding alpha, right? So bring the we can bring the 5 over. 2 alpha is k over 4 minus 5. Then you just divide by 2. Now, you can just leave it like this, k over 8 minus 5 over 2. Or if you want, you can combine them as a single fraction. Basically, you multiply this one, top and bottom, by 4. So your alpha is k minus 20 over 8. Yeah, k minus 20 over 8. Okay, moving on to question number 8. This is from chapter 7, coordinate geometry. So diagram shows the intersection of Jalan Mawar and Jalan Ros in a small town. There are stall A, B, C in the area. They're located close to each other as shown in the diagram. Okay, so OABC is a parallelogram. So OABC. So let me just draw A. Maybe I use a different color, easier to see. OABC. B is here. Oops, my line be ugly. C is here. So this is a parallelogram. So one of the features of parallelogram is that the midpoint of the diagonal, let's say this is your first diagonal, the red line, and the second, maybe I use a purple line, the midpoint of the diagonals are always the same. So we join together, there you go, this midpoint must be the same. Okay, they say if the position of the meeting place of Jalan Mawar and Jalan Ros, this is Jalan Mawar, this is Jalan Ros, they both meet at point O, is O, and is represented by 0, 0, the origin. Let's take the position of stall B and stall C. Well, I think we can find C first before you can find B. C, you notice, right? C, you go to the left by 75. So C is negative 75. Then you go up by 15. This is like your y-axis. These are your positive x-axis because O is 0, 0. You go to the left by 75. You go up by 15. So this is C. So maybe I write part A. Let me write here part A. Your coordinate point C is minus 75. Let me write here minus 75 and 15. So whereas coordinate of point B, you need to calculate. You need to use the midpoint of the two diagonal. Now, first, you need to know what's the position of point A. What's your A? A, you go to the left by 35, negative 35. You go up by 45. Okay, so this point A. I know that I need to let B be, let's say, XY. You can use HK, PQ, whatever, right? So your midpoint of OB must equals midpoint of AC. For OB, very simple. O is 0, 0. B is X. So 0 plus X over 2. 0 plus Y over 2. Now, for AC, I'm going to use negative 35 minus 75 over 2. 45 plus 15 over 2. So this will give us, we can actually cancel your 2 and 2, but never mind, just calculate this one first. Negative 110 divided by 2. This is 60 over 2. Just compare. Yeah, this is X over 2, Y over 2. Therefore, your X is negative 110. Your Y is 60. B is negative 110 and 60. Okay, fairly simple. Now, next, the question stated here that the shortest distance between the intersection of Jalan Mawar and Jalan Ros, which is O, and position of stall A, you're finding the shortest distance. Okay, actually, they should have just say find the shortest distance between O and A. The shortest distance in this case is just line OA. It's very simple. We need to know, or should I state the position vector of A first? A is not position vector, sorry, the coordinate point A. A is negative 35, 45. So if you are finding distance, OA, right? Let me write here, OA. We use formula for distance, 0 minus 35. So it's just positive 35. And 0 minus 45 square. Okay, use your calculator, 35 square plus 45 square, square root. Yep, you should get 57.09. Yeah, 57.001. For significant figure is 57.01 in meter. Okay. Another stall D is open such that the distance from stall A is 2.52 times the distance from stall C. Okay, so actually this part here is a bit misleading because they should mention that stall D lies on line AC. Otherwise, it's a locus. Why? Okay, let me rub all this off. I just clear up this line, easier to see. Okay, if position, okay, read this again. Stall D, distance from A is twice distance from C. Distance from A is twice distance from C. For example, your D can be here, right? Distance from A is twice distance from C. Your D can be, let's say, here. Distance from A is twice distance from C. Your D can be here. Distance from A, maybe I put this a bit closer. Distance from A is twice distance from C. It's locus, right? It's a moving point. Actually, yeah, it's a moving point. It could be a circle like this. I don't know, right? Unless we go and calculate, right? So I think, and the marking scheme give answer as though it is on a straight line. Yeah, it is, they use the ratio formula. So I guess the question would be better if they mention that stall D lies on a straight road connecting C and D, C and A. They should mention that because the marking scheme based on the formula nx1 plus mx2 over n plus n, ny1 n plus 2, ny2 n plus n, that formula. Okay, so I would just assume that to be true. The distance from A is twice the distance from C. So it looks like this. This is D to 1. Maybe I write this separately, a bit hard to show you here. So I'm going to draw another line. This is C. What is C again? 7515. Negative 7515. Your A is 3545. Negative 3545. Where's your D? D is somewhere here. Distance 2 to 1. This is x, y. So in order to find coordinate point D, right, we should use, D will be, this is, let's say we use mn, this is your m, this is your n, this is your x1, y1, x2, y2. So we take 2 times negative 75 plus 1 times negative 35, total ratio 1 plus 2. Then you go on with 2 times 15, 1 times 45, divide by total ratio 1 plus 2. Okay, so this will give us negative 75 times 2 is negative 150. Then you minus 35, divide by 3, answer is 185 over 3. 185 over 3. Second one, this will be 2 times 15 is 30 plus 45, divide by 3, this will be 25. There you go. That is the coordinate of point stall D. Okay, let's move on to question number 9. This is from the chapter Indices and Logarithm from 4, chapter 4. Okay, so diagram here shows a cylinder. It is given a radius of the cylinder is 4 sub 3 and the height is h, total surface area is 56 pi sub 6. So you're supposed to express h, the height, in terms of m sub 2 and n sub 3. Okay, yeah, in the form of m sub 2 and m sub 3. So I know total surface area of a cylinder is given by 2 pi r squared 2 pi r h. For those who don't know, right, when you take a piece of paper, should I say, a piece of paper like this, you roll it together. This length, if I join from here to here, it'll be the same as this circle. And this, it will be another circle, right? So the top part, the area is pi r squared, area circle. Bottom part also pi r squared. And we know the circumference here is 2 pi r. So therefore, the length from here to here is 2 pi r as well. The height of the cylinder is h. That's why if you add these two circles, is pi r squared plus pi r squared, you get your 2 pi r squared. You take your, what do you call that? The curved surface area. You take 2 pi r times h, you will get 2 pi r h. So your total surface area is 2 pi, your r is 4 sub 3. You square it, then you add with 2 pi r 4 sub 3 times h. Your area is 56 pi sub 6. Okay, so let's simplify this further. You square this first. 4 squared is 16. So you have 16 times 3. And then this, what you can add together is, you can times together 8 sub 3 pi h, and then 56 pi sub 6. Okay, 16 times 3 is 48. 48 times 2 is 96 pi plus 8 sub 3 pi h and 56 pi sub 6. So I can see, oh, we can divide everything by 8 and you can divide by pi, right? If you need calculator, go ahead. 96 divided by 8 is 12, right? So this is 12. This will be sub 3h. 56 divided by 8 is 7. The pi cancel out. So it's 7 sub 6. I'm supposed to find h. So I bring the 12 over. This will be negative 12 plus 7 sub 6. Yeah, you can put the sub in front at the back, doesn't matter. All right, so next we are going to divide by sub 3, or maybe I put, yeah, maybe I put 12 at the back. It's the same actually. 7 sub 6 minus 12. I now divide by sub 3. You can divide one by one, or you can divide one shot. I prefer to divide one by one. Sub 3. This is 12 divided by sub 3. Because sub 6 divided by sub 3 is just sub 2. So you have 7 sub 2 here. Whereas 12 divided by sub 3, right? We have to rationalize the denominator. Yeah, 12 sub 3 divided by sub 12 divided by sub 3, you times top and bottom by sub 3. Sub 3 times sub 3 is just 3. Then you just simplify further. You get 4 sub 3. So you see your answer is in this form. Yeah, sub 2 sub 3. Yeah, which I got that. Sub 2 sub 3. Therefore, your m is 7. Your n is negative 4. Yeah, but do you need to write down the value of m and n? No need. I just have to express in this form. All right, part B, involving logarithm. So here you're given log base pk is a, log base qk is b. You're supposed to show that log base k pq equals to this. We will start off by changing log base k pq, break it up first, because we need to change the base 1 to base p, another to base q, right? But we don't change it because we don't know whether it should change a k to q or p. So we break it up first. You can see there's a log base kp, multiply, break up becomes a plus. This is log base kq. Now, there are two versions for formula for changing base. One is the standard way. The first one is given exam. Log base AB is log CC. B stays on top, A stays down. C is your new base. The second version is not given, but it's quite easy. In fact, it's easier to do for this question. We just change the base C to B. So when you use log BB, log BA, what happened is log BB is 1. So this is just 1 over log BA. Notice that A and B will now change position. So that's what I'm going to do. I'm going to change this to 1 over log base BK. This one I change to 1 over log base QK. Reason being because I'm given these two information. I want to use this BK, QK, right? So log base BK is 1 over A. This is 1 over B. Combine them. We're supposed to combine them. See, the answer is given like this, so we should combine them. Cross multiply. B plus A is the same as A plus B, so it's A plus B over AB. All right. Now next, we're supposed to solve this logarithmic equation, part C. So this is involving exponential. I hope you know that ln simply means log base e. So you change from logarithm form to index form. 1 over x is e power 3. So I'm going to invert, because I'm finding x, right? X equals to 1 over e power 3, or you can write e power negative 3. Yeah? So you can use a calculator, because you're supposed to give your answer correct to 4 significant figure. So 1 divided by shift ln, that will be e power 3. Your answer is 0.04979. 0.04979. Okay. Okay, question number 10. So a participant in a mathematics quiz answer 40 multiple choice question such that each question has 4 choices, one of which is correct. The participant knew the answer to 35 questions and guessed the answer for the remaining question. Assuming that the participant answered 35 questions known, the 35 known question correctly, find the probability, guess all the question correctly. Okay, so let's begin. Now, number 10A. Okay, if you guess all the question correctly, remember there are 5 questions that he guesses. Okay, and when you guess a question, right, you can, there are the chances of you getting correct one from 1 out of 4, we say is 1 over 4, right? So if you guess all the question correctly, your probability is x equals to 5. We write NC Cn, in this case is 5C5, P is 1 over 4, power 5, Q is 3 over 4, power 5 minus 5. Okay, 5 minus 5 is 0. So it's basically 1 over 4 power 5. Okay, let me just use a calculator. 1 over 4 is this, power 5. Yeah. By the way, 5C5 is 1. So 1 over 1024. Okay, then estimate the number of questions answered correctly by the participant and explain your answer. Now, he already answered 35 correct. So the remaining 5 questions, right? If you want to, when you say estimate, means you're finding on average, the mean. Mean is given by NP. So if you have 5 questions that you guess, and the probability of guessing a correct answer is 1 over 4, this would be 5 over 4. 5 over 4 is 1.25. Can you use a calculator? 5 over 4 is 1.25. You can't do mentally, right? So if you want to estimate the number of questions answered correctly, so the number of questions will be 35, answer all correct already, plus 1.25, that is 35.25. Sorry, 36.25. So this is approximately 36. When we say estimate, we normally take the nearest integer. So the number of questions we estimate that answer correctly is 36. Now explain your answer. How do you explain? We can say the participant guess 1.25 question correctly. So and answer 35 question. Should I say the participant is estimated to guess 1.25 question correctly and answer 35 question correctly. So when you answer 35 question correctly and you guess 1.25 question correctly, so your total is 36.25. But we take the nearest integer, that would be 36. Okay, quite simple. Okay, question number 11. This is from Permutation combination from 5 chapter 4. So here we have parts label with 7 consonant and 5 vowel. Okay, so that 7 consonant and 5 vowels are placed on the table, and you're supposed to find number of ways to choose 10 letters if the number of consonant must be equal to the number of vowels. Okay, so you have 7 consonant and 5 vowel. Okay, so we want to choose. To choose means no arrangement. It is combination such that vowel and consonant must be the same. and you're choosing how many cards? You're choosing 10. So that's very obvious. I have to choose 5 and 5, right? So the first part is 7, consonant choose 5, 5 vowel, I choose 5. So the number of ways will be 7 choose 5 times 5 choose 5. 5 choose 5 is actually 1. So your answer is just 21. Okay. All right. Next, Roman 2. So find the number of possible arrangement if all 12 letters to be arranged in a circle such that the vowels are in separate arrangement. Okay, so first of all, I need to think this way, right? So normally when you arrange in a circle, let's say I got 12 cards and I arranged in a circle. So the formula is actually 12 minus 1 factorial. Now, why do we minus 1? Because let's say you got 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's say the first card is letter A. You can put A in 12 different positions here. You see that? 12 different positions. Because if you rotate it, like for example, okay, maybe I just give an example of you put, let's say A here, B on its left, C on its right. So when I rotate it, right, A can be, let's say here, B will still be on the left, C is on the right. Then you have the same cards on the left, on the right. So to prevent this arrangement, because you rotate it, they actually have the same arrangement, they're just at the different position. What we can do is we kind of fix or nail the first position, cross out the first position, fix the first one. Let's say I put A, cut letter A, put here. So, and then I arrange the rest, right? So the rest of the 12 cards will be, you left with 12, you take out 1, left with 11. That will be 11 factorial ways to arrange the rest. So it no longer rotate and having the same cards on the left and right, but they're just at different direction, if you like. A can be here, can be here, can be here, can be here. So when I fix the position, arrangement is, I mean, you don't have to worry about rotation. That's why we always minus 1. Now, coming back to this question, they say you have how many vowels? How many consonants? You have 7 consonants, you have 5 vowels. But the vowels, right, cannot be next to each other. They are in separate arrangement, yeah? You must read the Bahasa version, disusun berasingan. That means they are separated, basically, right? So how do you separate it? Now, if you arrange in the row, right, think this way. If you arrange in the row and you don't want the consonant, you don't want the vowel next to each other, you treat the consonant as the separator or the partition or the boundary, if you like. You put the 7 consonant. You put 8 empty spaces in between them. So then you put a vowel, right? However, circular arrangement is a bit hard for you to do this because you have to join them together. And there's a problem. If you join together, you see this empty space, this empty space, you join together, they are the same empty space, right? So what we do is we put the consonant on the circle. Let me just draw a circle. There are 7 consonants, so I put 1, let's say 2, 3, 4, 5, 6, 7. Okay, and that would have created 1, 2, 3, 4, 5, 6, 7 empty spaces between the consonants, so that the vowels will never be next to each other. Now, the thing is, you got to fix the position of the first consonant. You nail it, if you like, fix so that it doesn't rotate. Okay, so how many ways to put the consonant now? How many ways to arrange the consonant now? We say 7 minus 1 or 6 factorial, right? Initially you got 7, you take the first consonant, fix the position so it doesn't rotate anymore, right? You can only arrange the rest of the consonant. Now, you got to think, the next thing is you got to think there are 7 empty spaces between the consonant, and I need to arrange 5 vowels. The remaining 5 vowels, arrange them. Now, for example, you may have, let me use a different color. Let's say my vowel can be here, vowel can be here, vowel can be here, can be here, can be here. So you got some empty spaces, but doesn't matter the empty space, because why? The consonant, as long as the vowel not next to each other, the consonant can be next to each other, not a problem. Yeah, this consonant can be next to this consonant, not a problem. But you cannot put the vowel next to each other. Yeah, so that's why we say 7 arrange 5 to fill up the consonant remaining position. and we multiply together. So that will give us 6 factorial times 7 arrange 5. That is 1814400. 1814400. Now, just so you know, we cannot agree with the, I cannot agree with the answer in the marking scheme, right? So I will stick to this answer. I think this is the right way to do. You fix the consonant and then you place a vowel in between the consonant. Okay. All right. That is part 2. Let's move on to part 3. So find the number of passwords consisting of 4 letters and followed by 2 digits without repetition that can be formed if the sum of the digit must be 5. Okay, so picture this. If you want to choose a password with 4 letters, how many letters you have in the alphabet system, A to Z? We have 26. Yeah, 26 letters. So this will be 26. Now, the question say without repetition. That means if you put letter A, I can't put letter A anymore. Reduce by 1, 25. Next one, reduce by 1, 24, and 23. Now, the number, right, although we have less number to choose from, the problem is the sum of the digit must be 5. So what are the digits? You can, sorry, yeah, if the digit looks ugly, the word looks ugly, what are the digits? So that you sum plus together, you get 5. Okay, first one, we start with the smallest number. You can have 0. 0 plus 5 will give us 5. Okay, we can also do 5 plus 0. Just switch the order. 0 plus 5, 5 plus 0. Also 5, right? 1 plus 4 also give us 5. 4 plus 1 also give us 5. 2 plus 3 also give us 5. 3 plus 2 also give us 5. So how many different ways? There's 6. Now, so this one is just 6, right? No need to write anymore because it's a specific number. It's not like I have 2 options for the first one and 3 options for the second one. No, it must be, let's say the first digit is 0, second digit must be 5. So the sum is 5. First digit is 1, second digit must be 4, right? So that's why we have to, in a way, list out 6 possibilities. So the number of ways to arrange the password will be, now you can write 26 times 25 times 24 times 23. I think it's easier to use 26 arrange 4, then you multiply by 6. Why multiply by 6? Because there's 6 options to arrange a digit such that the sum of the digits is 5. Okay, so let's use our calculator and count 26. Okay, let's move here. 26 be 4 times 6. My answer is 2152800. 2152800. Okay, question number 12. So this one you have to use differentiation. It's part A, both actually differentiation. They say find the small change in the volume of a cube when each side increases from 2 to 2.02. Okay, so first of all, a cube, right? Let me just do a sketch. Looks like this. The length of side is x by x by x. So volume of a cube is x cubed. So we're going to use differentiation, right? So let's differentiate dv dx 3x squared. Now, initially, the cube has a length of side of 2 cm. So we substitute 2 inside, 3, 2 square, that gives us 12. Okay, so remember, the small change in, maybe I write down the formula, delta v divide delta x must give us dv dx. What is your delta v? I don't know. I'm finding the change in the volume. I know my delta x. When you go from 2 to 2.02, we take the finals minus initial, answer 0.02. Okay, your delta v divide delta x 0.02 equals dv dx, which is 12. Delta v is 12 times 0.02. Answer is this, 0.24. Okay, That's all. The change in the volume is just 0.24. You can use your calculator to validate how to do that. We know initially it is 2, then it goes to 2.02. So 2.02 cube, right? You type shift cube, you minus 2 cube. 2 cube is just 8. Your answer is 0.242408. Yeah, of course, this is approximation because you're using differentiation. Yeah, we assume that this is true when your delta x is small. Yeah, so from here it's not too far. Yeah, 0.2424. Your answer here is 0.24. Okay, let's move on to part B. Then I try to find the first derivative of this y equals x squared minus 2x minus 3 using the first principle, but was unable to continue her work. So help Danya to answer the question. So I'm not going to like copy the question, it's because it's done. Danya already did halfway. So this is your equation 1, this is your equation 2. So what we need to do, remember, the curve looks like this. The line that touches the curve at one point is called a tangent. This is your tangent. When you substitute a specific value, that's your gradient tangent, this is dy dx. Now there is another point on the curve. Let's say this point is x, y. There is a second point on the curve. Let's say it's over here. Is x plus delta x, y plus delta y. So when you draw this triangle, obviously you can see the triangle is different. This is a chord. The red line is a tangent. There are two different gradients. As we move the blue line closer to the red line, the gradient gets closer. Now, as you move it closer, what happened to your delta x? Your delta x is smaller. This is delta x. This is your delta y. As you move your delta x smaller, the triangle actually gets closer, and this tangent is now almost the same as tangent, your chord. So just make it even smaller, 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 you get this. So what we have to do is we have to use the concept of first principle here. dy dx is gradient of tangent. Delta y over delta x is gradient of chord. They are two different gradients. However, when you take the limit of delta x approaching 0, that is, you make this triangle small enough such that delta x almost 0, then the chord and the tangent will be the same. So up to here, Daniel has calculated y and y plus delta y. So we just have to take equation 2 minus equation 1. So when you subtract, right, what happened is your y can be cancelled out. You're left with delta y. Maybe I just zoom in a bit hard to see, right? Zoom in a bit. Okay, so you can cancel y and y here. You're left with delta y. Then you can also cancel x squared and x squared. What else? Minus 2 and minus 2. Okay, maybe I use a different color pen. Minus 2 and minus 2. And we can also cancel minus 3 and minus 3. So as you take equation 2 minus 1, you're left with 2x delta x plus delta x squared. There's another minus 2 delta x over here. Okay, so what we want to do is we want to find delta y over delta x, which is this one, the gradient of your chord. We divide by delta x, so delta y over delta x is now 2x plus delta x minus 2. Then we take dy dx as the limit of delta x approaching 0. So your delta x, delta y over delta x, this one, we sub inside 2x plus delta x minus 2. Replace your delta x with 0. So you get 2x plus 0 minus 2. Answer is 2x minus 2. Okay, remember, if you were to take this original function x squared to x minus 3 and you differentiate it, you should get 2x minus 2, which is exactly the same. Okay. Okay, moving on to question number 13. So here we have a function fx equals to 8 minus 6x minus x squared. So you're supposed to complete the square and give your answer in this form. So I think the first thing to do is when you complete the square, right, I think we can just leave the 8 out. So 8 is not involved in the process of completing the square. You can put the 8 in front, 8 in the back. Actually, it doesn't really matter, right? So for a lot of students, because you're so used to putting negative x squared first, right? So I'm going to do one by one, step by step. I keep the 8 at the back. So I factorize the negative. This will be x squared minus 6, if I take out negative, becomes positive 6x plus 8. Yeah, 8, again, like I say, it's not involved in the process of completing the square. We're going to leave it out. Now, then we're going to add a number. That number is half of 6, right? So we put 6 divided by 2. We square it, then you minus it off, right? Because you can't simply add a number to a function, then you change the value of the function. And so we're going to add this. Reason why we add it, because we're combine this to a perfect square term, and then you're going to minus it to balance out the equation. So this is x plus 3 square. 3 square is 9. Then you are going to take this negative and multiply inside. So it's plus 9 plus 8. That gives us 17. So I just put a 17 in front, minus x plus 3 square plus 17. Okay, that is your first answer. Okay, well, sorry, the 17 is in front, right, in this form. They say express in this form. Then they say find the range of fx. Well, remember, if your a is less than 0, your fx will be a maximum. And the maximum is the one outside the bracket. In this case, is 17. And it occurs when the one inside the bracket is 0. Okay, that is not important. What is inside the bracket not important? We know the maximum is 17. If your maximum is 17, that means it should be either 17 or less than 17. So that's why we write our range as fx less equals 17. All right, that is only part A. Now, I'm going to do part B here. They say this quadratic function fx equals to ax minus m squared plus n, where a is more than 0, has a negative discriminant value. So discriminant is your b squared minus 4ac. Yeah, if your b squared minus 4ac less than 0, means there's no real roots. If there's no real root, right, your graph can either be above the x-axis or below the x-axis. However, it is above the x-axis if your a is more than 0. It's below the x-axis if your a is less than 0. Rounding face, right? So for both cases, the graph shouldn't meet the x-axis because there's no real root, right? But here the question says that since a is more than 0, you can see here a is more than 0, we cannot take the one below. We have to take the one above, right? So we just do a sketch. However, before you draw the whole thing, as we also need to know whether it's minimum, what is the minimum value and the maximum. Now, based on this function that you were given, we can see that your fx has a minimum. My minimum is n. When the one inside the bracket is 0, x is m. Remember, this is your vertex. This is your axis of symmetry. Symmetry. Okay. So your vertex is n. Axis of symmetry is m. So when you sketch, right, you can draw like this. Let me just sketch nicely. Your vertex is n. Axis of symmetry is m. There you go, that's your answer. However, if you draw on the left-hand side, also okay, because the question didn't mention that your m is positive or negative. Your m can be left-hand side, your n remains the same. Yeah, you can draw the first one or the second one, doesn't matter. As long as it's above the x-axis, it's a smiley face like this, okay? All right, now let's move on to part C. I'm going to do C here. Find the range of values of x for which this inequality is greater than 17 using number line method. So let's expand now. 1 minus 2x squared. Sorry, let me write here better. 1 minus 2x plus x squared plus 2x greater equals 17. X squared. The minus 2x and 2x you can cancel. 1 minus 17, negative 16 greater equals 0. We can double bracket factorize. Plus 4 minus 4. Okay, so let's do a sketch, okay? Number line, right, we have to, nowadays, because in SPM, they ask about using table method. So they can ask you graph, they can use number line. Okay, as I say in the other video, right, number line is actually a simplified version of your graph. So a graph we always draw is a minimum like this, minus 4 and 4. This is positive, this is negative, this is positive. So it's always plus, minus, plus. But it's better to test this right? As in we show that we test in the diagram itself. Okay, I think I better give more space because I need to make this longer. Oops, sorry, a bit ugly. Make it longer so I got more space to write. Okay, so we pick a number, right? That is, your roots are -4 and 4. Pick a number that's slightly less than -4. Let's say -5. You minus 4, then -5, you minus 4. Just show that this is more than 0. So I know it's going to be more than 0, but just you can use a calculator, validate. Okay, so you can use this function, x minus 4, x. Okay, first is plus 4. The first one is plus 4, plus 4. Second one is x minus 4. You press calculate, pick a number less than -4, so -5. You see, it's positive, right? So you don't have to write down the answer as 9, just show that it's more than 0. So we know this is positive, okay? Right, then take a number between -4 and 4. The easiest is 0, -4, 0, sorry, plus 4. Sorry, this one is a plus, the other one is a minus only. This one -4, this is going to be less than 0, okay? Because you can see 4 times -4 is going to be -16. However, it's okay, you can use your calculator, put 0 inside, you can see it's -16, less than 0, okay? Then we take a number more than 4, maybe I put 5, 5 plus 4, 5 minus 4, this is going to be more than 0, confirm. So use your calculator, put a 5 here, you see it's 9, more than 0, plus. So the first inequality is supposed to be meant for x less than -4. Second one is between -4 and 4. Third one more than 4. Now, this one is my sketch, separate sketch, but it's not this answer. Because you want more than 0, you want the region to be greater equal 0, your inequality be greater equal 0. Therefore, your answer is x less equals. Please put a equals here, sorry, add in an equal sign. And x greater equals to 4. Yeah, two possibility. Okay, so I know number line, yeah, it's supposed to be easier, but here we are required to test the point. So that's why I test the point one by one to show you the working. And yeah, that's the answer. Okay, question number 14. This is from the chapter Trigonometry from 5, chapter 6. Okay, you are given f theta equals 5 sine x theta plus y. I think they shouldn't use x and y. Very confusing because your x and y is a y-axis, x-axis, right? However, by right, they should use b, c, maybe p, q, h, k. Usually those are used as constant. But anyway, you're supposed to state the value of x and y. They say that the period is 180. Normally, right, period is given as 180 divided by b, but in this case your b is your x. Okay, sorry, this is sine graph. Sine graph, the period is 360 divided by b is x, and the period is given as 180. We're supposed to solve for x, very simple. Bring the x up, bring 180 down. 360 divided 180, x is 2. Now, for minimum maximum, there are actually two ways to do it. Number one is to use a simple sketch. A simple sketch of graph right now. Graph of sine doesn't matter whether it's, in this case, 5 sine theta, right? So your amplitude is 5, -5. But the moment, okay, your x is 2, doesn't matter, you put 2 theta here. The moment you plus with y, this one you must plus with y. 5 plus y, this will be y. Let's change this to dotted line because you're either shifting up or you're shifting down. But we do not know whether your y is positive or negative. Doesn't matter, just a sketch of this. Now, then they say this minimum value is -1. So based on my graph, I can see that -5 plus y is -1. Your y is 4. Yeah, this is one way up. Quite easy, but I know some people don't want to sketch a graph. The alternative to this is to use the range of sine, right? I put the or. We know sine of 2, in this case is 2 theta, is always between -1 and 1. Okay, you can write x theta, in this case is 2 theta. Then you plus y on the left, you times 5 first, you times 5 on the left, you times 5 on the right. Everything times 5. Then you plus with y, okay, 2 theta plus y, this will be 5 plus 5. Okay, but because we are only interested in the minimum, this is your minimum. -5 plus y is now -1, y is still 4. Okay, so you can sketch a graph if you want. You can use the inequality for range of values of theta, also okay. That is part A. Part B, we need to sketch a graph. This is a different graph, cos 2 theta. Yeah, you're supposed to sketch cos 2 theta. Okay, maybe I move up a bit so I got more space. So this graph, right, is a normal cos graph. Will be like this. This is a normal cos x, one cycle from 0 to 360. In radian will be 2 pi, right? But we are not drawing cos, we're drawing cos 2x. So we need to do 2 cycle, 1 cycle, 2 cycle, up to 2 pi. So this will be pi. So where's 3 pi over 2? Here, 3 pi over 2. So in this case, you are drawing up to 3 pi over 2. So I don't want this, right? And your maximum 1, minimum -1. So let's draw a bigger graph. Let me draw here. Maximum, minimum. Okay, 0. We need to draw 6 segments, so you can draw like that. Break it up into 6 parts. If possible, use a ruler, measure at least like maybe 1 cm or 2 cm each. So make it like balance. This is your x. So we start from this is 1 down to -1. This is your y. Okay, so I like to plot the points. So it helps me to draw a balanced graph. Okay, so and maybe use a thicker line. Thicker line will be able to help you to hide the ugliness. Yeah, it's like putting foundation on the face. So it looks like this. Okay, this part is a bit ugly. Let me just fix it. Okay, all right. So there you go. I will label this as 3 pi over 2. This will be my pi. This is pi over 2. Now you can subdivide everything else. This divided by 2 is pi over 4. This is 3 pi over 4. This is 5 pi over 4. Just keep increasing by pi over 4. Well, my graph is done. Now, next is say on the same axis, sketch a suitable straight line to find the number solution to this equation. So we're going to do something with this equation. I think we have to rearrange such that one side equals to cos 2x. So I'm going to throw the 6x over pi to the right hand side. So I have 4 cos 2x equals -6x over pi plus 3. Then I divide by 4. 6 divided by 4 is 3 over 2 pi with the x. You can put the x here, plus 3 over 4. Okay, so the straight line that you have to draw is this. The easiest way to draw a straight line is to use the table of values. Take the smallest value is 0 from the graph. If you put 0 here, I got 3 over 4. Largest value is 3 over 2 pi. I put, okay, picture this, that is 3 over 2 pi. There's another, wait, it looks weird though. 3 over 2 pi. Then you plus 3 over 4. It looks weird because of the cancel here, because of the fraction, right? This is -9 over 4 plus 3 over 4. That'll be 6 over 4, which is -3 over 2. So it's a bit lower. Fortunately, we have a bit of space. This is 3 over 4. This is -3 over 2. So the first point, I'm going to use blue pen here. Second point is over here. Now you can use other additional point if you want, right? You can put your x-axis if you want. So I'm going to take a ruler and join this together, right? So remember, the number of solution is your number of intersection, right? So here, from the graph, I can see we have 1 and 2 solution. Yeah, 2 intersection. So therefore, from the graph, the number of solution is just 2. Okay, last question, question 15. This is from the chapter Indices, Surds, and Logarithm. This one involving indices actually. So we're supposed to solve this equation by finding k. So I think you can square and get rid of surd and all that, but I think maybe I just change everything to base 3 because I know 9 is 3 power 2. 81 is 3 power 4. Yeah, I changed my 81 to 3 power 4. Square root is power half, so I do very slowly. 3. 27 is 3 power 3. I do very slowly. 27 is 3 power 3. There's a power half here equals to 9. 9 is 3 power 2. Okay. Now keep changing the square root. There are two layer of square root if you like. This is 3 power 4. I keep this as 3 times 3 power 3 and a half because another square root. Let me put a different bracket. Another half equals 3 power 2k, right? Now, this is 3 power 4. This is 3 power 1 plus 3 over 2. Another power half, 3 power 2k, right? When 3 power 3 times half is 3 over 2, then when you times the number plus a power, so this is 3 power 4 and 3 power 5 over 2 power half. So 3 power 2k, very slow. This is again 3 power 4. This is going to give us 3 power 5 over 4. Okay, so again, we can add together. This is 4 plus 5 over 4. That will be 21. 21 over 4. Yeah, 3 power 2k. So I think we just compare. 2k is now 21 over 4. K is 21 over 8. Yeah, it's not difficult. It's just a bit annoying. You do like a lot of steps. Yeah, in between. Okay. All right. So that is the first part. Part A. Okay, second part. So here, after T years, the price of a car bought by Nick was 78,000 times 0.8 power T. When you have 0.8 power T, that means the price of the car, the value of the car depreciate by 20%. So we want to find the price of the car after 6 years. Okay. So the question say after T years. So that means T is 6. The price will be 78,000 0.8 power 6. I'm going to use my calculator. 78,000 times 0.8 power 6. I got 20,000 447.23. RM 20,000 447.23. Now the question didn't say give your answer correct to the nearest ringgit. So I think I'll just leave it up to cent. 20,000 447.23. Okay. Now then, second part. Find the minimum number of years that will take for the price of the car to be less than 30,000. So at one point, the car, the price, you keep dropping. At one point, you'll be less than 30,000. Okay, actually, you can see here it's just within a few years. Yeah, less than 30,000. Okay, so yeah, our job is to find the value of T. Okay, so let's just use logarithm. We cancel the 30,000 and 20,000, 78,000. We can simplify it. 30,000 divided 70,000. You cancel the zeros. 5 over 13. 0.8 power 6 less than 5 over 13. Introduce log on the left, on the right. Sorry, this one is power. I wrote this wrongly. Yeah, power T. Yeah, this is T. We're supposed to solve for T. Yeah, bring the power T down. This is LG 0.8 less than LG 5 over 13. Remember, whenever you take a logarithm between 0 and 1, it's going to be negative. Let's say you try shift log 0.8. You see this is negative. So how does this affect your answer? The inequality symbol has to change. Yeah, you have to change it. So we take log of 5 over 13. Then you divide by log of 0.8. My answer is 4.283. 4.282. Change the symbol, 4.282. So if it's 4.282, we should take what? T greater than. We should take 5. Yeah, that means after 5 years, the price will be less than 30,000. Yeah, we will show here when t equals 6 is already less than 30,000. Okay, next. Starting from the 7 year onwards, the car value depreciate by 65%. So Nick bought the car in 2018, find the value in 2027. Okay, so we can do it this way. 2018 is your first term, the first the zeroth term. He bought in 2018. After 1 year is 2019, right? After 2 years, after 1 more year or 2 years, it'll be 2020. Now, what is after 6 years? You basically you just plus 1, plus 1, plus 1. After 6 years, you plus 6. Let me just plus 6 here. You should get 2024. Yeah, this is after 6 years. Now, I need to do this because the first 6 years, right, it follow this formula. But the 7 year onwards, it follow a different formula, which is drop by drop by 65%. Yeah. Okay. So you depreciate by 65%. Okay. Okay, I think the question a bit, when you say depreciate by 65% means what? You depreciate by 10% means you drop 10%. Depreciate by 65%, you drop 65%, right? But the marking scheme shows that it is 65% of the actual value, right? Okay. Yeah. So we say depreciate by 65% means you drop 65%, right? So yeah. So which one do I follow? Do we follow yeah? Or we say depreciate to 65%. So I don't want to change, right? It's kind of weird. You drop by 65%. You should drop a little bit, right? Depreciate to, should I say depreciate to 65%, right? Depreciate to 65%. That means it dropped 35%. So it reached 65% of the value. Okay, so we want to know where's 2027? This is 2025, 2026, 2027. So every year you drop. Right now, there is a general formula. Some of you learned this in your geometric progression, right? That your Tn, you can combine with geometric progression if you want. So Tn equals to ARn minus 1. So your A is now the price in year after 6 years. The price after 6 years, actually we already calculated here. The price after 6 years is 20,447.23. So your A is 20447.23. Don't you put bracket? When you drop to 65% of the value, your R is 0.65. Okay. Then your N is now, okay, here's the thing. We cannot say N equals, sorry, I shouldn't use T3 because this is your T1. Yeah. This is your T2. This is your T3. 2027 is supposed to be a T4. Supposed to be a T4. This is 4 minus 1, which is 3. You can write 4 minus 1, you can write 3. Yeah. Why? 2024, the price, the value is 20,000. Yeah. At this year, the price is 20,447. After 1 year, is T2. After 2 years, is T3. After 3 years, is T4. So we can use our calculator here. This is 20,447.23 multiplied by 0.65. Okay, 0.65 power 3. answer is 5615. Wait, 5615.32. Okay, 5615.32. RM 5615.32. All right. Yeah. That's all we are done for this paper. I would say it's a relatively easy paper. Thank you for watching. I hope you learned something or a lot of things in the process. Hope to see you guys in the next video.